This tutorial, we're going to use the Pythagorean Theorem to solve some application problems. Number one, during a wilderness training exercise, Ada's team started by walking 542 meters due west. Gordon's team started by walking due north. After 15 minutes, the two teams were 798 meters apart. Both teams started at the same point. How far did Gordon's team walk in that time? Round the answer to the nearest meter. Now, you may not realize it, but this is a great problem to solve using the Pythagorean theorem. So, let's take a look at what we got. We've got, actually, a triangle, because Ada's team starts by walking 542 meters due west, right? 542 meters due west. And Gordon's team started by walking north, so they started walking this direction. We don't know how far they went. We know that they walked for 15 minutes, so we're going to make that x. But we do know that after 15 minutes, the two teams were 798 feet apart. So 798 feet apart here. Now, this gives us a leg and a hypotenuse of a right triangle, so we can solve this using Pythagoras' theorem. So the Pythagorean theorem says a squared plus b squared is equal to c squared. We've got a, and we'll call a x. So x squared plus b squared, which is 542 squared, is going to be equal to c squared, which is 798 squared. Now you can see right away that we're going to get some very large numbers. So what we wind up with is x squared plus 293,764, which is equal to 798 squared, which is 636,804. And then we're going to subtract from both sides. So we're going to subtract 293,764 from the other. So x squared, once we subtract this from both sides, we get x squared is equal to 343,040, right? And then we have to take the square root of both sides. The square root of 343,040 turns out to be 585.696, a big number. So we're supposed to round that to the nearest meter. That's going to give us 586 meters. And there we go. And let's try one more. Number 3, Mr. Allen wants a jasmine vine, a plant, to grow on a rectangular section of his front fence. For this to happen, the vine will need a wire for extra support. He attaches the wire at the bottom left corner of the rectangular section. He runs the wire diagonally to the top right corner of the rectangular section. The rectangular section has a length of 180 centimeters and a height of 135 centimeters. How long is the wire? Round the answer to the nearest centimeter. So what we're going to need first is a rectangle. And then we're going to need to draw a line across there. It always helps to have a picture. Always, if you can, draw the picture out. So he attaches a wire to the bottom left corner of the rectangular section. So he's got this. And he runs the wire diagonally to the top right corner of the rectangular section. So there he's got it. He's got his wire running across there to the rectangular part. Now, we're told that the rectangular section has a length of 180 centimeters, 180 centimeters right here, and a height of 135 centimeters. How long is the wire? Now this is our right angle right here, so what does that make this value? That's right, that makes that c, the hypotenuse. So we're going to use the Pythagorean theorem, a squared plus b squared is equal to c squared, and solve our problem. So a squared is 180 squared plus b squared, which is 135 squared, and that should be equal to c squared. 180 squared is 32,400 plus 135 squared, which is 18,225. That's going to be equal to c squared. And when you add those two together, you get 50,625 is equal to c squared. Now, just like always, I don't want c squared, I want c, so I've got to take the square root of c squared, and that is going to give me c, and then to keep it balanced, I've got to take the square root of 50,625, which turns out to be 225. So how long is the wire? The wire is 225 centimeters long.